Okay, so when x is 3, 3 squared minus 6 times 3, 9 minus 18 is negative 9. Okay, when x is negative 3i, okay, so here negative 3i times itself. Negative 3 squared is positive 9. I squared is I squared. And then over here, negative 6 times negative 3 is positive 18. And then still have the I. So remember that I squared is negative 1. So 9 times I squared becomes 9 times negative 1, which is negative 9. So this part becomes negative 9. Okay, and then when x is 3 minus I, all right, so over here we need to distribute because this is a binomial with two terms, so I'm going to do that off to the side. Okay, so 3 times 3 is 9, 3 times negative I is negative 3i, negative I times 3 is negative 3i, negative I times negative I is plus I squared. So negative 3i minus 3i is negative 6i, but I squared is negative 1. So positive 9 minus 1 is 8. So then 8 minus 6i, and then over here, negative 6 times 3 is negative 18. Negative 6 times negative I is plus 6i. So 8 minus 18 is negative 10. And then negative 6i plus 6i cancel out to 0i. All right, so if negative 8i is the root of a quadratic function, so hopefully you notice that whether doing quadratic formula or completing the square, it was always plus or minus the radical. So if this part turns into 8i, you could either have negative 8i or positive 8i. Okay, so similarly over here, if the only way to get 3 minus 2i is a root is if it was the plus or minus. So 3 plus 2i is also a root. Okay, so these are called conjugates, just like when we were rationalizing or getting rid of the I in the denominator. When the sign in the middle is switched, they're called conjugates. All right, so here we want to take out as many groups of 4 as we can, because remember, I to the 4th power equals 1 whole. So I to the 36th power, that's I to the 4th all to the 9th, which is positive 1 to the 9th, which is just 1. So now I to the 23rd. So I can form 5 groups of I to the 4th, and then I have still 3 left over. So again, I to the 4th is 1 times, or 1 to the 5th power is just 1, so that goes away. So now what does I to the 3rd power equal? Well, I to the 3rd power is equal to I squared times I, and I squared is negative 1. So negative 1 times I is negative 1. All right, and then I to the 89th power. So I can form 22 groups of I to the 4th. That uses up 88 out of the 89, and I just have a single I left over. So again, all these 1 to the 22nd power is just 1 times I is I. So 1 minus I plus I, these two cancel out, leaving just 1. Okay, so this one's new. So if the roots is 2 plus 5i, what is the equation of the function? Well, it might be helpful to think of a simpler situation. So let's pretend the roots are x equals 2 and negative 4. So we know from the zero product property, that would mean that it came from this, right? Because 2 turns it into 0 and negative 4 turns this into 0. So if you know the roots, you subtract them from x to get the quadratic equation. So in this simpler example, it would be x squared plus 4x minus 2x is plus 2x minus 8. Okay, so we're going to do this same process for this situation. So here I knew both roots. Only one root is given here, but I know whenever it's complex, whenever an I is involved, the two roots are in pairs. It's the positive and the negative version. They're conjugates. So these are the two roots. Okay, so just like over here, I do x minus the root. So x minus this, and then x minus that. Okay, so first I'm just going to distribute the subtraction within each. So minus 2 minus 5i, but then this one is minus 2 plus 5i. Okay, so I need to distribute here, which is going to take some room. So x times x is x squared, then x times negative 2 is minus 2x, and x plus 5i is plus 5ix. Okay, moving on. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times positive 5i is negative 10i. And then lastly, negative 5i times x is negative 5ix. Negative 5i minus 2 is plus 10i. Negative 5i times times positive 5i would be negative 25i squared. Okay, so let's do some simplifying. I know I squared is negative 1, so negative 25 times negative 1 is positive 25. Then negative 10i plus 10i, these cancel out. Plus 5ix and minus 5ix also cancel out. And that's it. So what do we have left over? We have x squared minus 2x minus another 2x is minus 4x. And then positive 4 plus 25 is plus 29. Okay, find the complex roots. So for this one, I'll use completing the square. And you could do the quadratic formula. So I'll subtract the 16 over. Okay, so my goal is to end up with this. So half of negative 4 is negative 2, which means that the missing term I need to add is negative 2 squared, which is positive 4. So negative 16 plus 4 is negative 12. Now I can square root both sides. So remember, when I square root, I create plus and minus. So negative 12, I can take the I to get rid of the negative. And then radical 12 is radical 4 times radical 3, which is 2 radical 3. And then lastly, add 2 to both sides. So 2 plus or minus 2i radical 3. So for this one, I'll use the quadratic formula. So x equals negative b plus or minus square root of b squared minus 4ac all over 2a. 4 squared is 16. Negative 4 times 3 is negative 12. Times 3 is negative 36. (16 minus 36 is negative 20. Okay, so negative 20 can be split up into negative 4 times positive 5, and square root of negative 4 is 2i. All right, so now all three terms are divisible by 2. So what's left over is -2 plus or minus I radical 5 all over 3. Okay, find the complex roots again. So an option is you could move everything to the other side or multiply through by -1 to get rid of all these negatives, but I'll just do it as it's written. So I'll use the quadratic formula again. Okay, -5 is +5. -5 squared is 25. -4 times -2 is +8 times -4 is -32. 2 times -2 is -4. 25 minus 32 is -7. And then I'll bring the negative out by turning it into an I. Okay, find the complex roots again. So I'll go back to the completing the square, because this time the a is 1, which makes completing the square pretty simple. Okay, so my goal is to get to here. Half of +6 is +3. So then 3 squared is +9. And since I didn't factor anything out, I just simply add 9 to the other side as well. Okay, so square root both sides. Remember to do the plus or minus. So to take the negative out, I make it an I on the outside. Okay, so cube root, so I'm looking to make things cubed on the inside. So 64 is equal to 4 cubed. A to the 7th power, I'll rewrite as a cubed times a cubed times a. And then b to the 4th, I'll rewrite as b to the 3rd times b. Okay, so what can I take outside? I can take a 4 outside. I can take 2 a's outside, so that becomes a squared. And I can just take a single b outside. All right, so what's left over inside the cube root? I have a single a and a single b. All right, here I'm looking for the 4th root, so things to the 4th power. All right, so 162 I don't have memorized, so I can always do a factor tree. So it's even, so I can always divide by 2. Okay, so it looks like 162 is equal to 3 to the 4th power times 2. And then x to the 10th, that lets me make 2 groups of x to the 4th and have x squared left over. All right, so what can we take outside? We can take the 3 outside. We can take 2 groups of x's outside. That's x squared. We cannot take the y outside, there's not enough, but we can take the z. Okay, so what's left over in the 4th root? We've got a 2 left over, we've got an x squared left over, and we've got the y squared left over. Okay, so here, combining the radicals, first we should simplify whatever we can. 5 can't be split up, but 40 can. So cube root, we're looking for things cubed. 40 is equal to 2 times 20, which is 2 times 10, which is 2 times 5. So 40 is equal to 2 cubed times 5. So let me just do this off to the side. So if I take the 2 outside to join the 8, sorry, to join the 4, now it's an 8. Okay, so remember when adding and subtracting radicals, we need both the index and the radicand to match. So even though these are all 5s in the radicand, we can't combine the cube root with the square roots. So -3 of something plus 2 of that something means -1 of that something. But this one cannot combine with the other two, so we just leave them separate. Okay, we have some distributing to do. -6 times -2 is positive 12. -6 times -3x. So negative times negative is positive. 6 is on the outside, keep the radical. Here, -2 times invisible 1, so that's -2 in front, keep the radical. And then positive radical 3x times negative radical 3x. So 3 times 3 is 9, x times x is x squared. All right, so these can combine because they're both square root and the radicand is both 3x. So 6 of those minus 2 of those means you have 4 of those left. And then square root of 9 is 3, square root of x squared is x. Okay, so here our denominator is a binomial separated by plus sign, so we need to multiply by the conjugate, which is the denominator with the middle symbol switched. So I'm going to put parentheses so that I remember to distribute everything. All right, so in the numerator, 2 times -3 is -6, 2 times negative radical 6, -3 times radical 6. Okay, so radical 6 times radical 6 is radical 36, or a regular 6, and positive times negative is minus. Okay, in the denominator, -3 times -3 is positive 9, -3 times negative radical 6 is plus 3 radical 6, positive radical 6 times -3 is minus 3 radical 6, and radical 6 times negative radical 6 is minus 6. So remember, the denominator should have your radicals cancel out. That's the whole point. So 9 minus 6 is 3. And then -6 minus 6 is -12. And -2 radical 6 combines with -3 radical 6 into -5 radical 6. Okay, so if you want, you can split this into 2 separate fractions. This one can't be reduced. You can't divide into a radical with a regular, but this part can. Okay, so either this or this is fine. All right, so here we've got square root of a negative. So we know the I comes out, and then 144 is 12 times 12. And here, again, I from the negative, and square root of 81 is 9. So 12i plus 9i is 21i. Eight x to the 9th power, all to the 2/3. So remember, with parentheses, everything gets affected by the outside exponent. So the 8 gets to the 2/3 power, and so does the 9. So when you have an exponent to another exponent, you multiply them. Okay, so I'll do the x part first. 9 over 1 times 2/3, I can reduce. So 6 over 1 is just 6. Okay, now 8 to the 2/3 power, I'll rewrite this as a radical. So remember, the denominator is the index, and then the exponent is the exponent, sorry, the numerator is still the exponent. So you could put the 2 inside. I'll choose to put it outside instead. So the reason I do that is because cube root of 8 is 2, and then 2 squared is 4. Okay, so if you do the squared on the inside, that's fine. That would just give you cube root of 64. And 64, 4 times 4 is 16, times another 4 is 64. So you see it does lead to 4 either way. Okay, so square root of y to the 1/4, all to the 8th power. Okay, so first I'll deal with this square root. So I have y to the 1/4 power. And then I know the square root means to the 1/2 power, right? Because the index is invisible too. Okay, so, and then this whole thing gets affected by the 8th power. So just working with the inside, the 1/4 and the 1/2 get multiplied. Okay, so 1/4 times 1/2 is 1/8. And then I multiply by the 8 on the outside. So I get y to the first power, or just y. Okay, so there's several things to do here. Let me rewrite everything with fractional exponents. So cube root of x is x to the 1/3 power. Okay, so this is a negative exponent, so I'm going to switch it to the denominator and make it positive. And then square root of x is x to the 1/2 power. Okay, so I can combine these in any order. I'll go sideways. So just looking at the numerator, when two terms with the same base are multiplied, you add their exponents. And similarly for the denominator. All right, so 1/3 plus 3/2. Common denominator will be 6. So that'll be 11/6 in the numerator. And then in the denominator, 1/2 plus 5/6. That'll be 8/6. And then to divide two terms with the same base, we subtract their exponents. So 11/6 minus 8/6 is 3/6, which reduces to x to the 1/2. And then we don't want to leave it with a fractional exponent, so x to the 1/2 is the square root of x. Okay, so several things to do here. So first this part, x to the -8th times 1/4, because exponent to another exponent you multiply. So this would be x to the -8/4, which is x to the -2nd power. Okay, but then that gets affected by the -1st power right here. And then -2 times -1 is +2. Okay, so this part becomes x squared. So let's look at what happens over here. So we have x squared all to the 1/3 power. When we have an exponent to another exponent, we multiply. So that becomes x to the 2/3. Okay, and then in our denominator, I'll just rewrite this as a fraction. So this would be x to the 4/6, but that can be reduced to x to the 2/3. All right, so these actually are the exact same terms, so we can cancel them out. We don't need to affect this because there's no plus or minus. This is all one term in the numerator. So the only thing left over is this x squared. Okay, irrational multiplied by irrational is always irrational. Okay, so we remember the things we always want to try are try the same number twice, try the opposite number, so the different sign, and we also want to try 0. Okay, so irrational times irrational. We can't use 0 because that's not irrational, but we can use the same number. So for example, radical 2 times radical 2 would be radical 4, which is regular 2, which is not irrational. So that means this is false because this is a counterexample. Okay, so sometimes it is true. For example, radical 2 times radical 3 is radical 6, but this is only sometimes true. We see that it can sometimes be false also. Rational added to irrational is always rational. So, well, let's try the situations. We can't use the same number. We can't add the same number twice because there's no number that's both rational and irrational. We can't do the opposite for the same reason. One of them will be, they'll both either be rational or irrational. So the only thing we can do is make the rational number 0. So if we pick 0 for the rational number and let's say radical 2 for the irrational, this equals radical 2, which is still irrational, which is not rational. Okay, so this is false then, right? Because rational over here plus irrational over here was irrational.